Hello everyone, I am here to present my talk on the topic of Open Telemetry and Microservices. I am Arvind Singharpuria and I am currently working as an MBA in Fountain. So let's begin this topic. So in the ever-evolving realm of software architecture, microservices has emerged as a dominant paradigm for building scalable and practical applications. However, the benefit of microservices come hand in hand with unique challenges, particularly in terms of observability. Open Telemetry is an open source tool designed to visualize the way we observe and manage microservice architecture. So let's talk about the microservice landscape. Microservices have become the backbone of scalable and flexible architectures, but they come with their own set of challenges. Now let's talk about the microservices challenges. Microservices with their decentralized and independent nature introduce challenges for developers and operators alike. Pinpointing performance bottlenecks, tracing the flow of requests, and ensuring the reliability of each service become intrinsic tasks in a distributed environment. Traditional monitoring tools often fall short in providing the granularity required for effective observability in microservices. Now, let's talk about some of the features of the Open Telemetry. So, first, let's understand what is Open Telemetry. So, Open Telemetry is a collaborative effort between the CNCS and other industry leaders. This is the challenges hands-on. It's comprising of APIs, libraries, agents, and instrumental standards. Telemetry offers a unified framework for collecting, processing, and for exporting telemetry data from applications. Let's deep dive into the key features that make Open Telemetry a game changer for microservice observability. So the first feature is the distributed tracing. At the heart of Open Telemetry lies its flagship feature, distributed tracing. In a microservice environment where requests will traverse multiple services, tracing their journey becomes paramount. Open Telemetry distributed tracing provides a comprehensive and real-time visualization of how requests move through various microservices. These traces capture essential data points, allowing developers to identify bottlenecks, understand dependencies, and optimize the overall performance of their system. Distributed tracing operates on the of creating a trace construct that follows a request across service boundaries. This not only aids in understanding the flow of requests, but also enables developers to diagnose and resolve issues efficiently. The result is a holistic view of the microservice landscape, empowering organizations to enhance the reliability and efficiency of their applications. Now let's talk about the performance monitoring. So beyond distributed tracing, Open Telemetry requires robust performance monitoring capabilities. It goes beyond the surface level understanding provided by additional monitoring tools, offering a granular view of key metrics such as response time, error rate, and throughput for each microservice. This performance metric feature transforms raw data into actionable insight. Developer and operator gain a real-time understanding of how each microservice is performing, allowing for informed decision-making and proactive issue resolution. Whether it is identifying a sudden spike in error rate or optimizing the response time of a critical service, OpenTelemetry performance monitoring capabilities empower organizations to stay ahead of potential issues. Now let's talk about some of the core features of OpenTelemetry. The first one is the context propagation. In a distributed environment, maintaining continuity at a request traverses different microservices is a non-trivial task. OpenTelemetry addresses this challenge with its context propagation feature, which includes trace contracts and baggage. Seamlessly travel with the request, ensuring that crucial information is not lost as it moves through the microservice architecture. Context propagation is the foundational to achieving end-to-end visibility. It enables developers to correlate events, logs, and matrices across services, facilitating a cohesive understanding of the entire request lifecycle. This is essential for effective troubleshooting, debugging, and overall system optimization. Now next is the instrumental standardization. One of the strengths of Open Telemetry lies in its commitment of standardized instrumentation. Microservices often involve a polyglot landscape, with different services written in various languages and frameworks. It provides a unique approach to instrumenting code, ensuring consistency in data collection practices across the diverse components of microservice architecture. This standardization simplifies the implementation process for developers. Whether you are working with a service written in Go, Java, Python, or any other language, OpenTelemetry offers a consistent way to capture telemetry data. This not only streamlines the implementation process, but also ensures that the collected data is uniform and interoperable, making it easier to adopt and maintain observability across the entire microservice ecosystem. Now let's talk about the interoperability. OpenTelemetry is designed with interoperability in mind, recognizing that different organizations have unique requirements. It supports multiple backends for storage and analysis. Whether you prefer Jira, Zipkin, Prometheus, or another solution, OpenTelemetry seamlessly integrates with a variety of backends. This flexibility allows organizations to choose the best tool for their specific needs. It also facilitates interoperability between different observability solutions, enabling seamless transition or integration as requirements evolve. Its commitment to being vendor agnostic ensures that organizations have the freedom to select the tool that aligns with their goals. Now let's talk about some of the benefits. First one is the proactive monitoring that we discussed above, but I will add few more points that it allows you to set up a hunting mechanism that based on predefined thresholds, enabling proactive monitoring. Now let's talk about logging integrations. So effective logging is indispensable for debugging and root cause analysis in microservice environments. OpenTelemetry seamlessly integrates with logging systems, bridging the gap between trace and log. This integration ensures that each trace is enriched with the relevant log data, providing a holistic view of the application behavior during a specific time frame. In a distributed microservices architecture, where a single request might traverse multiple services, creating logs this page become a game changer. OpenTelemetry logging integration allow developer and operator to trace the flow of a request across services and simultaneously access detailed logs associated with each service. Now let's talk about dynamic environments. The dynamic environments are inherently dynamic, with service being added or removed dynamically based on demand. OpenTelemetry is purpose-built to thrive in such dynamic scenarios, providing insight into the performance of service regardless of their life cycle. The ability to adapt to the fluidity of microservice architecture is a standout feature of OpenTelemetry. As services scale up or down in response to changing workload, OpenTelemetry ensures that observability remains uninterrupted. The contract propagation mechanism and instrumentation standard in OpenTelemetry facilitate a seamless transition from monitoring newly introduced services. Its adaptability is crucial for maintaining a cohesive view of the entire system, ensuring that observability scale alongside the microservice system. So, for getting started with the OpenTelemetry, you can go to their website and it's a straightforward way to install, configure, and start using Open Telemetry. And I want to conclude that Open Telemetry is really a game changer for microservice observability, offering distributed tracing, standardized implementation, and interoperability. It can directly unlock a new level of understanding and control in your microservice architecture. Uh, Thanks a lot, and let me know if you have any questions for me. Thank you, everyone. Bye.